Welcome children. Monashri ma'am here, starting acid, base and salts in chemistry. Okay children, so let us learn more about acids, bases and salts. A very important chapter. In fact, this is basis of many other chapters also that you will be learning in the future. So let us learn in detail more about acids, bases and salts. Okay, so let us define and learn more about each and every term. Now, acids. The definition of an acid. An acid is a substance that generates hydrogen ions. Okay, that means it produces hydrogen ions, which in turn produces hydronium ions when added to water. Let me explain to you once again. An acid is a substance that generates hydronium ions. How? By liberating first hydrogen ions when added to water. Okay. So, an acidic solution is a solution with a significant concentration of hydrogen ions. Okay. So, now let me explain to you in detail. Now, as I told you, all acids, that means compulsorily have hydrogen as their constant element. Then only they can release hydrogen ion. Okay. Now, for example, hydrochloric acid, that is hydrogen chloride gas, when dissolved in water gives hydrochloric acid. Now, first of all, hydrochloric acid has hydrogen as its constituent element present in it, and this hydrogen chloride, when it is dissolved in water, this hydrogen chloride gas, or when dissolved in water, you get hydrochloric acid. And in this aqueous solution of hydrochloric acid, you have first HCl breaks up as H plus and Cl minus ions, and this H plus together with the in the water molecule, it forms with the water molecule, it forms H3O hydronium ions. Okay, so this is the hydronium ion. Hydronium ion is H3O plus. So how did this H3O plus form? The H plus ion produced by the hydrogen chloride gets attached to the water molecule, forming hydronium ion. Okay, so that is why acids are defined as, an acid is a substance that generates hydronium ions, that produces hydronium ions when added to water. Okay, so the actual source of hydronium ion is from the H plus ion released. Okay, the H plus ion released gets attached to the water molecule and forms hydronium ion. So an acidic solution is a solution with a large concentration of hydronium ions. Is it clear, children? So that is the definition of an acid. Now, examples of acids, so you have so many examples: hydrochloric acid, sulfuric acid, nitric acid, acetic acid. All these are examples of acids. Okay, examples of acids. Now, acetic acid, what you use at home as vinegar. Citric acid, the lemon juice, orange juice, they are nothing but they contain citric acid. Tartaric acid, tamarind, grapes, they all contain tartaric acid. Then all citrus fruits contains this ascorbic acid. Then milk and yogurt contain lactic acid. Apples and pears contain malic acid. And stings, the sting of the ant also contains acid, that is called formic acid. So these are certain organic acids. Okay. Then you have inorganic acids. like hydrochloric acid. These are all organic acids. Organic acids are acids which are found in organisms or living things or vegetable material. Okay, so these are organic acids. Okay, now inorganic acids are hydrochloric acid, then you have sulfuric acid. Okay, then you have nitric acid. Okay, these are some other examples of acids. Okay, so now, so let us again revise. How do we define acids? Acids are defined as compounds which contain one or more hydrogen atoms and when dissolved in water produce hydronium ions H3O plus as the only positively charged ion. So now you must understand the definition clearly and be able to write it. So acids are defined as compounds which contain one or more hydrogen atoms and when dissolved in water produce hydronium ions. That is H3O plus as the only positively charged ions. As the only positively charged ions. Clear, children? So that is the definition of acids. Okay, so let me again explain. Hydrogen chloride, thus HCl, in presence of water gives first H plus and Cl minus ions. Then this H plus ion gets, this H plus ion cannot exist independently. So it combines with the water molecule forming hydronium ion. Okay. So this hydronium ion now can exist independently in solution. Okay. So now for example, sulfuric acid. Sulfuric acid when dissolved in water gives two hydronium ions because it has two H ions. Okay. Two hydronium ions plus sulfate ion. Okay. SO4 2 minus. Okay, then nitric acid. Nitric acid when dissolved in water gives one hydronium ion plus nitrate ion. Okay, so these are some of the examples. So this is nitric acid. HNO3 is the chemical formula of nitric acid. H2SO4 the chemical formula of sulfuric acid. And hydrogen chloride and HCl you know already you have learned. That is the formula of hydrochloric acid. Okay. Clear, children? Now we will learn the types of acids. That is monobasic acid, okay, monobasic acids, dibasic and tribasic acids. To know these, we must first know the definition of basicity of acids. Okay. So, first we will learn what is meant by basicity. Basicity of acids. Now, what is this basicity of acid? The basicity of an acid is defined as the number of hydronium ions that can be produced by one molecule of the acid in aqueous solution. Listen carefully. What is basicity of acids? Basicity of acid is defined as the number of hydronium ions. That is H3O plus. Number of hydronium ions produced by one molecule of an acid in its aqueous solution. So, if an acid produces one hydronium ion, then it is called monobasic. If one molecule, that is per molecule of the acid, if it produces one hydronium ion, then the acid called monobasic acid. If each molecule of the acid produces two hydronium ions, then it is called dibasic acid. And if one molecule of the acid produces three hydronium ions, then it is called tribasic acid. So examples are hydrogen chloride and nitric acid. They are monobasic acids as they produce per molecule they produce 1H plus, and this 1H plus goes and combines with water forming one hydronium ion. Okay. So monobasic can be defined also as the number of hydrogen ions produced per molecule of the acid. Okay. In more simpler terms, it is the number of H plus ions produced by per molecule of the acid. Similarly, sulfuric acid per molecule produces two hydrogen ions. So these two hydrogen ions get attached to two water molecules and produce two hydronium ions. So therefore sulfuric acid is a dibasic acid. H3PO4, that is phosphoric acid. What is H3PO4? Phosphoric acid. Phosphoric acid. It has three hydrogen ions, so it produces 3H3. That is why it produces three hydrogen ions, and these three hydrogen ions produce three hydronium ions. So therefore it is a tribasic acid. So is it clear? So monobasic acid which produce one H plus ion per molecule, thereby producing one hydronium ion per molecule in its aqueous solution. So such acids are called monobasic acid. The examples are hydrochloric acid and nitric acid. Dibasic acids are those which produce two hydrogen ions per molecule of the acid, thereby producing or generating two hydronium ions per molecule of the acid. Such acids are called dibasic acids. And tribasic acids are per molecule they produce three hydrogen ions, so thereby generating three hydronium ions per molecule. Okay. Now here is a very important question and oft repeated question, that is acetic acid. The formula for acetic acid is CH3COOH. So total number of hydrogen atoms in this molecule is, one molecule is 4 hydrogen atoms. But This acetic acid is monobasic. Acetic acid is monobasic acid. Explain or give reason. Okay, so this is a very oft repeated question. So what is the explanation? That though acetic acid in its molecule has 4 hydrogen atoms, that is 3 here and 1 here, but still when it dissolves in water, it breaks up as CH3CO minus and H plus ion. So it produces per molecule only 1 hydrogen ion, and this 1 hydrogen ion reacts with water and forms hydronium ion. 1 hydronium ion. Okay, so that is why acetic acid, though has 4 hydrogen atoms in its molecule, but still it is a monobasic acid, because when it is dissolved in water, it splits up as acetate ion, CH3CO minus and 1 H plus ion, and this 1 H plus ion generates 1 hydronium ion, and that is why it is a monobasic acid. Okay, clear? Next, now acids are again classified as strong acids and weak acids. Strong acids and weak acids. Okay, now let us learn how they are classified as strong acids and weak acids. Okay, now first of all, what is a strong acid and what is a weak acid? A strong acid is one which completely dissociates and produces, which every molecule dissociates and produces high concentration of H plus ions, and thereby generating high concentration of hydronium ions. Okay, now like for example this hydrochloric acid, nitric acid, hydroiodic acid, perchloric acid, chloric acid, all these are strong acids, and these acids they under every molecule dissociates, forming H plus ions and thereby generating hydronium ions. Whereas weak acids, every molecule does not dissociate. Some remain as molecules and some only dissociate, forming H plus ions. So such acids, they will have in their aqueous solution some molecules which have not dissociated into ions and some hydronium ions. So the number of the concentration of hydronium ions, or the number of hydronium ions in the solution, aqueous solution, will be lesser. So therefore they are called weak acids. So strong acids are those acids which undergo dissociation completely, means every molecule breaks up, dissociates, forming H plus ion and thereby generating hydronium ion. So such acids are called strong acids, and acids which undergo partial dissociation and produce less number of hydronium ions, such are called your weak acids. So these are the examples. Okay. So we have already learned basicity of acid. Let me revise once again. Basicity of acid is the number of hydrogen ions present in the acid. So HCl is monobasic. It ionizes producing 1 H plus ion, and this 1 H plus ion again forms 1 hydronium ion. Now H2SO4 is dibasic because it produces 2 hydrogen ions, which in turn generate 2 hydronium ions. And H3PO4 phosphoric acid is tribasic because each molecule produces 3 hydrogen ions and thereby generating 3 hydronium ions. Okay. So let us summarize. Hydrochloric acid formula is HCl, chemical formula is HCl, and the common name is muriatic acid. And uses, the uses are also very important, uses of acids. So uses are, they are used in as toilet cleaners, then they are used as masonry cleaners, they are also present in the gastric juice, they are used as metal cleaners, and they are used in sugar and to make sugar and glue. Then carbonic acid formula is H2CO3, carbonated water, acid of air, these are the common names, and they are used in club soda, soft drinks, etc. Then sulfuric acid is known as battery acid, formula is H2SO4, and it is used in battery, air pollutant mist, and acid rain. Then nitric acid formula is HNO3, it is known as aqua fortis or spirit of nitre, and it is used in removing warts, causes yellow stains on the skin. Okay. Then phosphoric acid is 3PO4, orthophosphoric acid is the common name. It is acidifies soft drinks, component in ATP and DNA. Then lactic acid, the formula is HC3H5O5. Okay, it is also called milk acid, builds up in muscles during exercises. Okay, so these are the uses of acids. Okay, then we will learn about this. We have finished learning types of acid and its uses. Okay, now we will learn how acids are manufactured or prepared. Okay, so now preparation of acids. Now in this preparation of acid, you have to only be thorough with the chemical equations. So one method is called synthesis, where direct combination of hydrogen and non-metal are used. Synthesis of hydrogen and one non-metal gives an acid. Okay, so here for example, H2 plus Cl2 gives HCl. Okay, so here hydrogen, chlorine is a non-metal, they combine to give hydrogen chloride acid. Similarly, hydrogen plus bromine gives hydrobromic acid. Okay, similarly hydrogen plus sulfur gives H2S, which is also acidic. Okay, then we have the second method of preparation. First one is synthesis, direct combination. Then the second method is by action of water on non-metallic oxides. Water plus non-metallic oxide. They are also known as acidic oxide because they produce acids. Give acids. Okay. So water, that is H2O, plus non-metallic oxide like sulfur dioxide gives sulfuric acid. Now with sulfur dioxide you get sulfurous acid, that is H2SO3. This is sulfurous acid. And sulfuric acid you get when water and sulfur trioxide, that is SO3 reacts, you get sulfuric acid. Okay, so this is sulfurous acid and this is sulfuric acid. Then you have water plus carbon dioxide gives carbonic acid, H2CO3. This is carbonic acid. Similarly, you have phosphorus pentoxide plus water, that is H2O, plus phosphorus pentoxide gives phosphoric acid, 2H3PO4. Okay, that is called phosphoric acid. Similarly, nitric acid you will get by reacting water with nitrous oxide, that is N2O5 gives nitric acid. Okay, or one more you can say, this is with water when nitrogen dioxide reacts. Okay, so you get two acids. Okay, now when water and nitrogen dioxide react, you get HNO2 plus HNO3. HNO3 is nitric acid and HNO2 is nitrous acid. Nitrous acid. So this is a very important reaction. In general, this reaction, chemical reaction, is asked independently as write the chemical reaction in which a acidic oxide reacts with water forming two acids. Okay, or just write a chemical reaction in which you get two acids. So nitrogen dioxide plus water gives nitric acid and nitrous acid. Very important reaction. Okay, then you have by the oxidation of non-metals, that is a third method of preparation. Third method of preparation is oxidation of non-metals. Okay, a non-metal, for example sulfur, when non-metal like sulfur reacts with an acid forming another acid plus water plus oxide. So for example sulfur plus nitric acid, which is an acid, when they react you get sulfuric acid plus water plus nitrogen dioxide. So when sulfur reacts with nitric acid you get sulfuric acid. Similarly, when phosphorus reacts with nitric acid you get phosphoric acid, that is H3PO4 plus water plus nitrogen dioxide. Okay, so these reactions are important. They may be asked as write the chemical reaction in which an acid produces another acid. So here nitric acid reproduces another acid, that is sulfuric acid. Nitric acid produces phosphoric acid. Okay, then the last method of preparation of acids is by displacement. Now in displacement method, a salt reacts with a less volatile acid producing another salt plus acid which is more volatile. Okay. So the equation is, say, salt, that is NaCl, sodium chloride, plus less volatile acid, sulfuric acid. Volatile means which does not evaporate at normal temperatures or low temperature. H2SO4 gives a salt, that is sodium bisulfate plus hydrogen chloride. Okay, so this is a more volatile acid. Similarly, sodium nitrate NaNO3 plus sulfuric acid gives sodium bisulfate plus nitric acid. Okay, so these are the methods of preparation of acids. Then the properties of acids. Acids are sour to taste, but we should never taste it because many acids are harmful also. Okay, so but there in general acids have a sour taste, and many acids like sulfuric acid, nitric acid, they are corrosive in nature. Therefore, they should neither be touched or neither be tasted. Then some acids are solid and some are liquid at room temperature. So mostly they are liquids. Okay, like acetic acid, formic acid, carbonic acid, hydrochloric acid, nitric acid, sulfuric acid. These are all liquid acids. Now in solid state you get boric acid, oxalic acid, sorry, boric acid, oxalic acid. These are all solid acids. Tartaric acid, even citric acid you get in the solid form. Okay, so these are some of the examples of acids which exist in liquid as well as in solid state. Okay, now as I told you, effect on skin, all mineral acids have corrosive action on the skin and therefore they cause painful burns on the skin. Okay, and sulfuric acid, conch sulfuric acid stains the skin black, and conch nitric acid makes it yellow, and hydrogen chloride gives amber color to the skin. Carbonic acid and organic acids are not corrosive. What are organic acids? Which are found in fruits, vegetables, which contain carbon as one of the element. Okay. Then acids also change color with indicators. Now indicators are complex substances that acquire separate colors in acidic and basic mediums. So for example, litmus indicator is a natural coloring matter obtained from certain lichens and dissolving in distilled water. So these indicate litmus always turns blue to red in acidic medium. Methyl orange turns orange to pink. Phenolphthalein remains colorless in acidic medium. Okay. So now chemical properties. So now chemical properties of acids. These were physical properties. Now chemical properties. Very important. Now reaction with metals. First property, reaction with metals. Now active metals react with both dilute acids and concentrated acids. So they even react with dilute acids, forming the corresponding salt, and hydrogen gas is released. So for example, magnesium, which is a metal, reacts with acid, hydrochloric acid, forming salt, that is magnesium chloride, and releasing hydrogen gas. Similarly, zinc plus hydrochloric acid gives zinc chloride plus hydrogen. This is also the chemical reaction for laboratory preparation of hydrogen. Similarly, iron plus sulfuric acid gives ferrous sulfate, that is FeSO4 plus hydrogen. Okay. Now, nitric acid slightly behaves in a different way. So, nitric acid is a very strong oxidizing agent. So, it is not used in the preparation of hydrogen. Why? Because it oxidizes hydrogen and forms water. Thus, defeats the purpose of the reaction. So, only magnesium and manganese can produce hydrogen with very dilute nitric acid. Okay. So, manganese plus dilute, very dilute nitric acid gives manganese nitrate plus hydrogen gas. Okay, then the next property is reaction with bases. Whenever acids react with bases, they form salt and water. These are also called, this reaction is also called neutralization. This reaction with bases is also known as neutralization reaction, because acids neutralize bases to form salt and water. That is why these are called neutralization reaction. So, say sulfuric acid, when it reacts with a metallic oxide CuO, it gives salt, that is copper sulfate plus water. Similarly, now when nitric acid say reacts with sodium hydroxide, gives sodium nitrate plus water. So whenever acid and reacts with a base, you get salt and water. Okay. Now, next property with carbonates and hydrogen carbonates, or they are also known as bicarbonates. Okay. Like for example, carbonates, CaCO3. What is this? Calcium carbonate. Plus, say hydrochloric acid gives calcium chloride plus water plus carbon dioxide gas. Okay, so with carbonates, similarly with bicarbonates, calcium bicarbonate, CaHCO3 plus hydrochloric acid gives calcium chloride plus water plus carbon dioxide. Okay. Then the next property. Decomposition of sulfides and bisulfides. So, whenever a sulfite or bisulfite, for example, CaSO3, calcium sulfite, plus hydrochloric acid, you react, they form calcium chloride plus water plus sulfur dioxide. This is also a gas. So with carbonates and with bicarbonates you get carbon dioxide gas. With sulfides and bisulfides you get sulfur dioxide gas. For example, with bisulfide, that is sodium bisulfite plus hydrochloric acid gives sodium chloride plus water plus sulfur dioxide. Okay, then with sulfides, the earlier one was sulfides. Okay, previous to this we learned bicarbonates and carbonates. This is with sulfides. Now with sulfides, that is zinc sulfide plus hydrochloric acid gives zinc chloride plus hydrogen sulfide gas. Okay. Similarly, ferrous sulfide plus sulfuric acid gives ferrous sulfate plus hydrogen sulfide. Okay. Now, chlorides do not react with any of the dilute acids. Okay. But chlorides react with concentrated sulfuric acid and when heated. Okay. So, NaCl, that is sodium chloride plus conc sulfuric acid, and when heated, if it is